Let's go back to our book clustering scenario. In a previous demo, we have shown how to cluster books based on a brief textual description, and we developed our machine learning model in a Jupyter Notebook using open source Python libraries. Now, say we want to operationalize the training. If in 1 month our bookshop owner adds some entries in his book inventory, it's a good idea to refresh the model. And we want to be able to do that just pushing a button. So we want to bring this code into a pipeline. Let's create a new pipeline. When you create the pipeline, you have the possibility to choose between a lot of different templates. So now we want to create an artifact for this task, so we will use a Python producer. Here is the template we get. It starts with a read file operator, so the template is assuming that we are reading some input data from a file. Then this data is passed to a Python operator, that is where the machine learning model is supposed to be trained. The results of the model is sent to this artifact producer that is basically persisting the model binary file in the machine learning scenario in Data Intelligence. And this second output connected to the Python operator is passing a model quality metric that can be, for instance, the accuracy or the precision to the machine learning scenario. So once both model and the metrics are saved in Data Intelligence, the pipeline execution is ended with the graph terminator. For our specific book clustering task, the input data were not taken from a file, if you remember, but they were extracted from HANANA database. So here, instead of taking the model from the data from a file, what we can do is using the custom operator that we created in the previous demo. And I have configured it to connect to the HANA database as soon as it gets triggered. So if we open the script, you can see that I have adapted it for our use case. I have added the code for the text preprocessing, the word embedding, and at the end, the clustering algorithm. I'm saving the pickle file, so the k-means artifact, and sending it to the first output port. And here I have added a quality metric that is called silhouette. It is a metric that sometimes is used to describe how good is the result of the clustering. So you see here that this code has quite a lot of dependencies. So we are using NLTK, GenSim, scikit-learn, etc. So when the pipeline will be running, you might wonder where it will take all this library from. And by the way, where is the pipeline actually running? How do you control the version of Python that is used to train this model? So if you check here, you see that I have added something called a group to our operator. And this group has a tag. This tag actually is the name of a container that we want to use to host this operator during the execution of the pipeline. So this node will run in a Docker container, so an environment that we have defined in advance, where we have created all the libraries that we need. And we can check out the content of this container by going to the container tab and checking the docker file. This is the recipe that we use to create the environment we want our Python operator to run in. So let's get back to the pipeline and start the execution. It will ask us how we want to name the artifact that will be produced. And then we just need to wait a few minutes for the completion. So at the end, if everything goes fine, you see the k-means artifact is created and the quality metrics is associated to this artifact.